All right. Hi, everybody. My name is, introducing myself first. My name is Vijay Anand Pillai. I'm one of the students for my course, which is the Bachelor of Psychology with Honors. And today I'll be presenting a presentation based on my studies, which is statistics for psychology. So let us not delay the time. Let us move forward to the first slide, which is today, what I'm going to introduce is the structural equation modeling, which is also called SEM. Yeah. So what is SEM? SEM is actually a diverse set of methods used by scientists doing both observational and experimental research. Yeah. SEM is also used mostly in the social and behavioral sciences, but it is also used in epidemiology, businesses, and also in other fields. So the history of SEM is where in 1972, the birth of social science research, SSR, which is a structural equation modeling, was experiencing a decade-long birth, moving from its origins to genetics to social and behavioral sciences. Sociologist Otis Dudley Duncan, 1966, reinforced the earlier design and extended the awareness of Sewell's rights, 1921. O.D. Duncan introduced SEM to the social science in his 1975 book, blossomed in the late 1970s and 80s when increasing computing power permitted practical model estimation. So in 1987, Haydock provided the first book-length introduction to structural equation modeling with latent variables, and this was soon followed by Boland's popular text, which is in 1989. So what are the assumptions that we need to see using SEM? First one is whether the data contain reasonable measurements of appropriate variables. Yeah. And whether the second one, which will come in, is whether the model case are causally homogeneous, where it makes no sense to estimate one model if the data cases reflect two or more different causal networks. The third one will be whether the model appropriately represents the theory of features of interest, where the models are unpersuasive if they omit features required by a theory or contain coefficients inconsistent with that particular theory. The fourth one is whether the estimates are statistically justifiable, where this is a substantive assessment may be devastated by violating assumptions, by using an inappropriate estimator, and or by encountering non-convergence of iterative estimators. Okay, and the fifth one is the substantive reasonableness of the estimates. So what is this? These are negative variances and correlations exceeding 1.0 or negative 1.0, and which are impossible, statistically possible estimates that are inconsistent with theory may also challenge theory and our understanding towards the study. And sixth one is the remaining consistency or inconsistency between the model and data. The process minimizes the differences between the model and data, but important differences may remain. All right. So let's go to the next slide. Using of SEM. So in using the SEM or building one, we will need to specify some sets of variables that can be attached towards the study. So building or specifying a model requires attending to the set of variables to be employed. Okay, and what is known about the variables, what is presumed or hypothesized about the variables, causal connections and disconnections, what the researcher seeks to learn from the modeling, and the cases for which values of the variables will be available. Example, kids, workers, companies, countries, cells, accidents, cults, so on and so forth. Model specification is not complete until the researcher specifies which effects and or correlations, covariances are to be included and estimated. which effects and other coefficients are forbidden or presumed unnecessary, and which coefficients will be given fixed, unchanged values. Example, to provide measurement scales or even latent variables. So here you can see the examples of SEM in one of the research. In this figure, figure 1, A, X, and Y are observed variables. Right? Motivation and satisfaction are latent variables and are errors variables. The relationship between these variables is divided into measurement model and a structural model. So figure 1, A is a path diagram of a structural equation model, while B, as you can see, are examples of equivalent models. Yeah. So let's come to strength and limitation of SEM. Because structural equation modeling SEM has become a very popular data analytic technique, it is important for clinical scientists to have a balanced perception of its strengths and also limitation. We review several strengths of SEM with a particular focus on recent innovations. Example, latent growth modeling, multi-level SEM models, and approaches for dealing with missing data and with violations of normality assumptions. That underscores how SEM has become a broad data analytic framework with flexible and unique capabilities. We also consider several limitations of SEM and some misconceptions that it tends to elicit. Major themes emphasized are the problem of omitted variables, the importance of lower order model components, potential limitations of models judged to be well-fitting, the inaccuracy of some commonly used rules of thumb, and the importance of study design. Sorry. So, the conclusion of our research is that novice researchers must take care of assumption and concepts of structure, equation modeling while building a model to check the proposed hypothesis. SEM is more or less an evolving techniques in the research, which is expanding to new fields. Moreover, it is providing new insights to researchers for conducting longitudinal investigations. So, the references that you can have a look at is based here. So all the references that I've done is based on what I've taken from the internet and uploaded on my presentation.